We're going to focus now on Lewis structures. So we've got covalent bonds here. We need to be able to draw a Lewis structure first before we can worry about the shapes and the larger shapes and then the function and the properties. So next page, we are working on Lewis structures and a couple things about the compounds we're working with here. So they will be molecular compounds, right? All nonmetals. We will have covalent bonds. You're not going to see charges, and we are always sharing electrons. You will actually see a charge down here, and you never need to worry about this nitrate down here, but we're not going to see charges holding things together, okay? So as we draw these Lewis structures, they're going to help us see where the valence electrons are and where the bonds are. As we draw our Lewis structures, here's the 3 steps we're going to take. So first we need to know how many valence electrons each atom has. And so to remind you, on our periodic table here, here's hydrogen. Hydrogen's in group 1A, so that tells me it has 1 valence electron. Any element here is in group 2A, so it has 2 valence electrons. Skip the transition metals, we won't be using those. Group 3A, 3, 4, 5, 6, 7, 8, and those are my valence electrons. And we learned in chapter 2 how to draw those dots for valence electrons. So I'm going to figure out that hydrogen has 1 valence electron, and I've got 2 of those. And then the second thing is I want to figure out how to arrange those atoms relative to each other. So I want to arrange the atoms with the least electronegative atom in the center. That's usually going to be the atom listed first in the formula, like here in CH4, that's going to go in the center, N is going to go in the center, and you also want symmetry, okay? That's easy if I just have this, what we call diatomic molecule. It's going to be symmetrical or even anyways. Then I want to draw Lewis dots on each atom. And remember, those Lewis dots are going to represent your valence electrons. And then you're going to connect them until you get the octet rule or 2 electrons for hydrogen. Because hydrogen, if you remember, only needs to get 2 electrons to have helium's electron arrangement. So I've got my 2 hydrogens. I draw the dots facing each other to kind of set them up for success for a bond. And then I'm going to switch colors just so you can see it. But here is a covalent bond that I just drew. Okay. When you draw these, make sure the line that you draw to form a bond actually connects to the dot. So it's very obvious that those dots are now connected. And just to connect this further to a particle picture, this would be an example of a H2 molecule. So this bond right here is the 2 electrons, the 2 dots that I see in that bond there. All right. So I will let's see, I'll do the F2 also. All right. So figure out how many valence electrons fluorine has. Here's fluorine, 7 valence electrons. And I'm going to remember, don't pair those until you have to. So 4. And then I'm going to put 5, 6, 7. I'm going to leave the unpaired one facing to the middle in preparation, kind of thinking ahead for a bond. Again, 1, 2, 3, 4, 5, 6, 7 valence electrons. And then I'm able to connect, make that line touch both of those. So that would be F2, all right? Don't get excited and put 2 lines or 3 lines if all I need is a pair here. And then electrons tend to be stable when they're in pairs. So we're always aiming for 2, 4, 6, 8, or 2, 4, 6, 8. There's that octet that each fluorine has now. And I don't need to draw any more lines. As long as I have my octet and bonds, I'm great. All right. That might look like this, just different colored atom, right? So next up, O2. Oxygen, if you look on the periodic table, how many valence electrons does it have? You should find 6. So I'm going to draw 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. Again, leaving the unpaired electrons towards the middle. Unpaired electrons are what connect to form bonds, okay? So I'm going to draw a single bond here. Now, I noticed something new that I haven't seen before. There's still unpaired electrons here, 1 on each oxygen. And so those are going to connect with each other. All right. Now, our goal is to get an octet, right? So if my goal is to get an octet, I can check that I have an octet here. This oxygen has 2, 4, and then 6, 8 total electrons. So that's good when I'm thinking octet. Now granted, these are shared, right? But that's what we do in a covalent bond, is we share. This oxygen has 2, 4, and shares 2 and 4. So this oxygen also looks and says, yeah, I have 8 also. Okay, you don't have to draw those circles. I was just kind of showing them to illustrate what was happening. I can redraw this to make it a little bit neater if you want, add extra symmetry. So double bond in the middle, lone pair, I just scooted them around, lone pair, lone pair. And if I was to build that with my atoms, then it would look like this. All right. Last one, let's try this N2. So nitrogen has 5 valence electrons. And so I'm going to connect. Oh, still have unpaired electrons. And you can't pair electrons within the same atom. If I share with myself, that doesn't really help me out, right? But if I share with my husband or share with my friend, then that's going to help us both out. So we always share with another atom. You don't share within the same atom. So now notice I have a triple bond, and if I count it up, I have 2, 4, 6, 8 electrons. If I redraw this, there is nitrogen. That's actually the bulk of the air that we're breathing, is nitrogen gas. And here's nitrogen. See that cool triple bond? So that is my nitrogen. So see if you can do those on your own, and then we'll come back in the next video and work on drawing some harder structures.